Hello, my dear class 10 students, welcome back. So today we are going to start a new chapter, and this will be the last chapter for chemistry portion. We have completed the first 4 chapters. So the name of the chapter would be periodic classification of elements. Okay, now you have the modern periodic table in your textbook, right? So this did not happen in a snap. Okay, the periodic table that we have today, it did not happen in a snap. Now today we have 118, okay, we have 118 elements. We have 118 elements in a periodic table. Out of that, like 98 elements are naturally occurring. Clear? Out of that, 98 are naturally occurring, and before in 15th century or in 16th century, in 17th century, what happened was there was no any classification. Okay, there was no classification. So with time, there was a discovery of new elements. With time, there was discovery of elements one by one, and it became hard. So there was one scientist. Okay, there was one scientist. His name was Antoine Lavoisier. Okay, Antoine Lavoisier. In 1789, this Lavoisier in 1789, he classified the elements. Okay, there was the need to classify the elements, right? So he classified the elements into metals and non-metals. Clear? Metals and non-metals. But it did not help, because like I said, with time there was more and more elements which was discovered, and there were some elements, okay, that shows both the properties of metals and non-metals as well, and we call them as metalloids, right? Metalloids. Metalloids are those which exhibit both the properties of metals and non-metals. So this Lavoisier in 1789, though he did a good job, he classified elements into metals and non-metals. Okay, now the major step was taken by Dobranier. Okay, so now I'll just give you an introduction and we'll study this one in detail. So Dobranier, he was a German chemist. Okay, Dobranier in 1817, he also he gave a law of triads. Okay, he gave a law of triads where he also played a very important role. So the idea of atomic masses, right? The idea of atomic masses is given credited to this chemist. Okay, a German chemist, Dobranier. Now the third one, we have Newland law of octave. Okay, so it was in 1860. So this then it came like this one. Okay, the third one is Newland law of octave. So this Newland, he also gave another law. He tried to improvise what Dobranier did. Okay, and during this Newland time, there was only 56 elements. Okay, 56 elements. Then after Newland, it came this Mendeleev. Now this Mendeleev played a very important role. The idea of the rows and column in the periodic table was all his idea. Clear? After that, we have this modern periodic table. So it was a long journey. Clear? It was a long journey. The modern periodic table that we have today, it did not happen in a snap. Okay, there were more than, now I have mentioned 5 scientists' names, but there are more. Okay, but these are the name of the most notable one. Okay, so there are many scientists who gave their models. Okay, models. So now before we start this Dobrenier, okay, this is very simple. The first one is Lavoisier. First, he did this classified elements into metals and non-metals. But with time, it was hard because more and more elements were discovered, okay, and there were some elements which exhibit both the properties. So this Dobrenier came. But now, before this, I explain this Dobrenier law of triads in detail, let me give you a brief point about today's modern periodic table, okay? Okay, so students, the modern periodic table today we have 118 elements that I have already said, right? Okay, so the 118 elements. And do you know how many groups and how many periods we have? Clear? So students, today we have seven period, okay, 7 period. Now, when I say 7 period, I'm referring to the horizontal rows, okay, horizontal rows. Clear? So means, see, the first period, right, horizontal, second period, third period, fourth period, 5th period, we have like a 6th period, and we have 7th period. So in modern periodic table today, we have 7 horizontal rows, and that is known as period, okay? So these things you have to know, okay, before we start this early classification, okay? So that is period. Clear? So I'm sure now you know in a periodic table which one we call period, okay? So we call these horizontal rows as period. So you will find 7 horizontal rows, okay? And they are known as periods. Now how many groups we have? We have 18 groups. 18 groups, okay? That means, students, this vertical column, okay? This vertical column are known as groups, okay? So we have 18 groups. Now keep this in mind and you note it down, okay? We have 18 vertical groups. So we'll start from 1, 2, and it will end in 18, okay? So in the modern periodic table, we have 18 groups. And if you are asked like, what is group, okay? In a periodic table, you will say that is a vertical column, okay? We have 18 vertical column. Now students, it is, you know, like it is arranged in such a way that like it's very systematic. Just by knowing the position of an element, we can know its property. Clear? And students, now this we have 4 blocks, okay? We have 4 blocks. We have 4 blocks. In modern periodic table, we have 4 blocks. So this group 1 and group 2, they are known as S block, okay? Group 1 and group 2, they are known as S block. And we have group 3 to 12 is known as D block, okay? D block. So you have to get familiar with the name, okay? Just the name, okay? So this D block we will not study in class 10. This you will study in class 11 and 12, okay? But you have to know that this part is the D block. Group 13 to group 3 till group 12 is D block. Now from 13 till 18, okay? 13, 14, 15, 16, 17, 18. We have 6 group here. 13 till 18 is known as P block. Clear? 13 till 18 is known as P block. So we have S block, P block, D block, and below in the modern periodic table at the bottom you will see 2 periods here like this, right? So that would be F block, okay? Lanthanides and actinides, okay? So that will be F block. So we have 4 blocks, okay? we have 7 period, we have 18 groups. Clear? And then this group 1 and group 2, this group 1 is known as alkali metals, okay, alkali metals. Group 1 is known as alkali metals. Clear? Now group 2 is known as alkaline earth metals. Alkaline earth metals. Clear? This, when I say group 1 and group 2, that means this one and this two, okay? So group 1 is known as alkali metals and group 2 is alkaline earth metals. That means these are like metals, okay? Metals. So see, they are arranged everything systematically. Clear? So here you will find the metals. Alkali metals, alkaline earth metals. Now, group 18, okay? This group 18, these are also known as inert pair group, or they are known as noble gas, okay? Noble gas. Group 18 is known as noble gas. Group 18. Clear? And group 17, these are the halogen family. Halogen family. In carbon, in the last chapter we have studied about this halogen family in the functional group, right? Where we studied about the chlorine, bromine, iodine and all. So group 17 is the halogen family. Clear? So these are few facts that you have to keep in mind, okay? And afterwards we are going to study in detail about the trends, okay? The trends in this modern periodic table. So these are the few facts you have to keep in mind, okay? So now we'll start with the early classification, how the journey began, okay? How the journey began. And so we'll start with Dobrynyer law of triads. Okay, so student, now we'll discuss about this law of triads, okay? Triads, okay? This is Triads. Now, this happened in 1817, okay? 1817. Now, this full name, okay, that you don't need, but full name is Johann Wolfgang Dobrynyer, okay? Now, he's a German chemist. Now, in 1817, he gave this law of triads. So, students see, just from the name, triads. Now, why it is triads? Tri means tree, right? Tri means tree. Right, tri means tree. Now, what he did, after Lavoisier classified the elements into metals and non-metals, but it failed, right? Because there were more elements which was discovered with time. Now, what this Dobrynyer did was, he formed a group, okay? He formed a group of three. Now, he divided the elements into a group of three. So, in one group, how many elements are there? There are 3 elements. That's why it is also known as triads, law of triads, okay? So, now what he did? He arranged the element in a form of group, and in one group there were 3 elements, okay? So, first group he was able to discover was lithium, sodium, potassium, okay? This is the symbol, lithium, sodium. So, now what he did, he arranged their atomic masses, okay? He arranged the atomic masses, their atomic masses in the order of increasing order. Increasing order. Clear? So, he formed a group of 3 and he tried to arrange them in the order, increasing order of atomic mass. So, students, lithium, the atomic mass is 7, sodium, the atomic mass is 23, potassium, the atomic mass is 39, okay? So, these are the atomic mass. Now, students, in increasing order, the first one will be the smaller one. So, lithium, the atomic mass would be 7. Sodium, the atomic mass would be 23. Now, Potassium, the atomic mass would be 39. Okay. Now, are you clear so far? Till here, he formed a group of 3 elements, arranged them in the increasing order of atomic mass. And he said, what did he say? Okay, through this law, what did he say? He said that whenever we take the average, okay, whenever we take the average of these 2 atomic mass, that means 7 plus 39. Whenever we take the arithmetic mean, okay, whenever we take the arithmetic mean of the first and the third atomic mass, then what will happen? Let's see. Clear? 39, 46. So, if I divide this one, I'll get 23. He said that whenever we take the average arithmetic mean of first and third, then it will be equal, okay? It will be similar or roughly similar with the atomic mass of the second. So see, when we plus these 2 together, the result is getting similar with the second one, right? We are getting the atomic mass of the second, okay? So that is known as law of triads, clear? Taking the arithmetic mean of the first and third, the result will get the similar with the second one, okay? First and third equal to second. So that is all about this law of triads. But why this law fell? Okay, why this law was not successful? Because he was only able to discover 3 triads. Clear? He was able to discover only 3 triads. So the first one we have already, the first one was this one, right? This one was successful. And the second was calcium, strontium, barium. Okay, this was also successful. Clear? Chlorine, bromine, iodine. So he was successful for only 3 triads. Okay, he was able to discover only 3 triads, and after that he tried to do, but it was not the arithmetic mean of the average atomic mass of these 2 was not equal with this 23. It was very far, okay? It was not roughly similar as well. So that's why this law failed, okay? So if you are asked in exam, what was the main reason of the failure of this Dobrynyer law of triads, then you can say that he was able to discover only 3 triads. After that, the elements he was not able to get the result, okay? Now, what was the significant of this Dobrynyer law of triads? Now, the main significant was the idea of this atomic mass, okay? The idea of this atomic mass, we can give credit to Dobrynyer. Clear? Atomic mass, still we are using this property till today. So he gave the idea of this one. Clear? So that is all about the Dobrynyer law of triads. Next class we'll discuss about the new lane law of octave, and then the most important one, Mendeleev periodic table. Clear? So thank you so much. See you in the next class.